Welcome back everybody to lesson 22 of the Dead Earth game development series, brought to you by the Game Institute. I'm Gary Simmons, and in this lesson we are going to develop our alerted state for our AI zombie state machine. Before carrying on though, I just want to address a slight typo that found its way into my code at the end of the last lesson. I don't think I probably would have spotted this for quite some time to come, so I have to thank you fellow folks out there in the GI community for pointing this typo out to me on the GI forums. So it was actually in our AI state class, and if we scroll down to the function convert a sphere collider to world space, you can see here that when we calculate the position of the center point of our sensor sphere, I'm doing pos x, pos y, and then pos y again, instead of pos.z. So we were never correctly calculating the z component of our sphere's center point, and furthermore we were also overwriting a correctly calculated y component with the z component. So now that has been fixed, and of course in the zip file that accompanies this lesson I will put up a modified version of this script. Okay, so let's go back to our project and start working on our alerted state. We saw in the last lesson that when we developed our patrol state wasn't really a self-contained state. Because we don't have animations that involve root rotation, we're going to use the alerted state to turn our zombie on the spot, even when it's just in a patrol state. So if I call up our AI patrol state from last lesson and scroll down to the onUpdate function, just to remind you, you can see that of course, if we have the player within our view cone, which is the only way that the player would actually be a visual threat, then we don't go into the alerted state. The visual player threat will only happen if the zombie can actually see the player. So we go straight into the pursuit state, which is a state that we will be writing in later videos. If the threat is the player's light, now remember we did say in earlier lessons that the player is going to have a flashlight, and that flashlight is going to be represented as a trigger that's going to be attached to the player's hierarchy. And that's going to have a script on it that when it intersects a zombie is going to kind of push itself as a threat into the zombie's queue. And when we have a visual threat like this, it doesn't necessarily mean the zombie can see it. The light might be shining on the back of the zombie's head, for example. And when this is the case, we want the zombie to drop into an alerted state, which is going to have that zombie seeking left and right on the spot, trying to find where that light source is coming from. And the same is also true of an audio threat. An audio threat will register itself as a threat as long as it's within the zombie's sensor trigger, but it might not be in front of the zombie or even within the zombie's view cone. For example, think of a sound that is being emitted behind the zombie. The zombie would still hear it, but it might not know initially where that sound is coming from. So that is the more obvious case where our alerted state would be used. But remember, our patrol state also drops to the alerted state if the target is a waypoint, but if the waypoint is at such an extreme angle from the direction that the zombie is facing that we wouldn't want to see the zombie rotating through such a wide arc on the spot. So when that's the case, we're going to kind of drop into the alerted state and in a way reuse the alerted state for a different purpose, simply so that we can have the zombie stop at one point along its path and then adjust itself by turning on the spot until it's facing at its new steering target, and then it will once again resume the patrolling state. So that's already been written. And of course this is true for our idle state as well. If we go to our idle state that we wrote a few lessons ago and go down into its onUpdate function, you can see once again that if there is a flashlight threat that is not within the view cone, or there is an audio emitter threat, then we drop into the alerted state too, and that will see our zombie turning on the spot, trying to ascertain the direction that that threat is coming from. So our alerted state really needs to work in a kind of dual mode. If it is an actual threat rather than just a waypoint target that we're heading towards, then when the zombie is turning left and right on the spot, it's going to be trying to get the actual position of the threat within its view cone. Whereas if we're heading towards a waypoint, it's going to be trying to get the position of the next steering target within its waypoint. Now the reason I make this distinction is because when our zombie is seeking to align itself with an actual threat, it doesn't necessarily mean that the steering target is in that direction. For example, we might hear a sound behind us, we might turn around such that we're now facing the threat, but in order to get to that threat, the zombie may need to head off to the left left and follow a convoluted path to get to that threat. Whereas in the waypoint case, we are just trying to align ourselves directly with the very next steering target. Now, you might think in the case of a normal threat that we would also want to align the zombie with the steering target as well, but to me, it just doesn't look right. It doesn't make sense. I think it makes much more sense to have the zombie try to find where the actual threat is and then automatically follow the path to get there, even if it means that it has to go off hard left or hard right to follow that convoluted path. So that's how this alerted system is going to work. So let's get straight to it. Let's go to our project view and let's drill down into our Dead Earth folder, into our scripts folder, and into our AI folder. And I'm going to create a new C# script, and I'm going to call that AI zombie state underscore alerted 1. Remember, I put this 1 on the end of each of my states because we may decide further down the road to create many different variants of these states. Perhaps another alerted state that behaves in a completely different way and makes the zombie exhibit a different behavior. Let's open that up in MonoDevelop. So the first thing we will do is we will delete the boilerplate code. And of course, our AI zombie states do not derive from mono behavior. They derive from AI zombie state, like so. And as with our other states, one of the first functions that we will implement is the getStateType function, which all derived states must support. Remember, this is what the state machine calls to ask the state to identify itself, and that function must return a member of the AI state type enumeration. So remember, that function is called getStateType. It is a public function that must override the method from the base class. It returns a member of the AI state type enumeration and takes no parameters. And of course, in this case, we will just return AI state type alerted. So let's think about some of the properties that this state is going to need to expose. When the zombie drops into an alerted state, like we've said, it's going to try seeking left and right, and it's going to be trying to ascertain the direction of the threat. Whether it manages to actually ascertain the direction that the threat is coming from is going to be largely random and influenced very heavily by the intelligence property of our zombie. Therefore, there is a chance that a zombie that's extremely dumb, or just has generated for it the wrong sequence of random numbers, may not be able to correctly ascertain where the threat is coming from. And in this case, we wouldn't want our zombies stuck in the alerted state for too long. So what we're going to do is we're going to have a timer in this class, which is going to time how long we've been in the alerted state. And then we'll have a variable that allows us to define the maximum time the zombie is to stay in this alerted state before it gives up trying to find the threat and then just resumes its patrol route. So I'm going to make this a serialized field. It's going to be a float, and I'm going to call it max duration. Okay, this is the maximum number of seconds that we are allowed to stay in the alerted state before we give up. And as a default, I'll just use a value of, 10 seconds. Sounds good enough to me. In fact, what I'm going to do is I'm also going to use that range attribute so we get a nice slider bar in the inspector. And I think probably a sensible maximum range for this would be maybe 60 seconds. I don't think we ever want a zombie to be in the alerted state seeking on the spot for more than a minute. So I'm going to say that the max duration can be between 1 second and 60 seconds, like so. If I save that off, go back to the editor, I have an error. Of course I have an error because I haven't yet implemented the onUpdate function, which every state must implement. So let me go and implement that right now before I forget. So once again, we need to override this function. It's a public function. It also returns an AI state type, and it's called onUpdate. So for now, until we flesh out this function, we will just have it return AI state type alerted. Because remember, our onUpdate functions, if nothing happens that changes the state of the object, it just continually returns its own state so that the alerted state can continue from one frame to the next. And if we go back to the editor now, I need to select OmniZombieGill's AI entity object, and I need to add my AI zombie state alerted 1 script to that object. And you can see down the bottom, if I close up some of these other components, we now have our AI zombie state alerted 1 component with that max duration, which is set to 10 seconds by default. Good stuff. So we're also going to need a private variable in this class that can be used for keeping track of time. So I'll just make this a private float called timer, and this needs to be set to 0 by default. So now let's override the onEnterState function, which is the function we use to set up a state so that it's ready for its updates. And like we did with the patrol state, I think we'll start by just copying and pasting most of the onEnterState from our idle state, okay? Because that contains most of the things that we need, and we don't have to type all that stuff out again. So let me paste it in there just after my getStateType function. And of course we will remove some of this code that only pertains to the idle state. And I'm also going to change that debug log to say now entering the alerted state. Bam, bam, bam. And like with our other states, we want to configure the nav agent to control our movement but not control our rotation. We do also want speed to be 0. We also want seeking to be 0 when we first enter this state, and of course feeding needs to be false, and we're not attacking, but we certainly don't want to clear the target, because if we clear the target, and remember this target may have been set by the idle state or the patrol state, we're not going to know what the target is that we should be seeking towards. So we won't clear the target, we'll get rid of that line, but apart from that the rest of it can stay. We just need to add a few extra things. Actually, we just need to add one extra thing, and I'll add it at the bottom, and we just simply need to set our internal timer variable to that max duration. Okay, and then what we'll do in our update is we'll continually count down from max duration down to 0, and when timer reaches 0 we'll know that the max duration has been exceeded, and we will drop back out of the alerted state and we'll return to, I think, the patrol state. So before I carry on, let me put some comments in here. Okay, so the next thing we'll do is we'll start to flesh out our onUpdate function. We don't need an onExit state in this particular state, so onUpdate is our next port of call. So the first thing we'll do in our update function is we will update our timer. We need to keep track of how long we've been in the alerted state. Remember, when we first enter the alerted state, our timer is set to max duration. So what we need to do each frame when the onUpdate function is called is decrement our timer by time.delta_time. Now we've done that, we need to check to see if our timer has hit 0. If there are 0 seconds left on the timer, then we've been in the alerted state too long, and we need to transition out of it and back in to the patrol state. The next thing we need to do is do a series of conditional tests, much like we've done in our previous states update functions. We need to assess the new audio and visual threats, which are updated each frame, to see if a new threat has become available, which may mean we need to immediately transition out of the alerted state into, for example, the pursuit state. So the first thing we'll do is we'll check to see if the visual player, remember that's our character in the game, has now become a visual threat. This is the highest priority threat, and it will only be a threat if it is within the zombie's view cone. If the player is now visible to the zombie isn't going to care about what sound source or what light source it was trying to seek to before. It sees the player, it's going to drop into pursuit mode and head straight for him or her. So we'll say if the zombie state machine's visual threat.type is AI target type.visualPlayer, we'll then make sure we set this as the new target for our state machine and transition out of this state immediately and into the pursuit state by simply returning AI state type.pursuit. Next, I'm going to check to see if there is an audio threat, and if there is, we're going to set that as the new target. Remember, the audio threat is a much lower priority than the visual player threat, but we don't have to worry that we're doing it after the above conditional, because if this condition is true, we return immediately out of this function, so the code that follows will never be executed. So I'm going to check if we've got an audio threat, and if we have, we're going to make that the new target. Now it may be that the reason we're in the alerted state in the first place is because that's the same audio threat that we're seeking left and right trying to find. But it may be a new sound that has been made while we're in the alerted state. Either way, the effect is the same. When we hear a sound, we go into the alerted state, trying to ascertain the direction of the sound. Therefore, if we still hear a sound, we still want to remain in the alerted state. We don't have to put ourselves into the alerted state again from the alerted state. We can simply set that audio source as the target and then just set our timer back to the max duration. So I'm going to say if zombie state machine.audio threat is AI target type audio, then set this as the new threat and set our timer back to max duration. In other words, we're saying please stay in the alerted state. There's still a sound being emitted and we may not have ascertained the direction of that sound source yet. A little later in this function, after we've done the conditionals, you're going to see the code that does that extra step that says if it is an audio source and it's within our view cone, well then we're going to transition out of this state into the pursuit state. But we're going to do that at the bottom of this function. Next up, we're going to do a test to see if we have a visual threat that is the player's flashlight. Notice that we do this underneath the test for the audio threat because the player's flashlight is a higher priority threat than the audio threat. Remember, when we process the audio threat, we don't return from the function like we do when we're processing the visual player. Therefore, by doing it in this order, we make sure that if there is a player flashlight and we set that as the target, it's just going to overrule anything that we've set here. The flashlight, just like an audio threat, is one of those threats that will put the zombie into an alerted state. Think about, for example, a zombie that may be walking down a road with his back to you. You shine a flashlight on his back, it's going to go into the alerted state. So just like with our audio threat, where we keep setting the timer back to max duration, while a flashlight is illuminating a zombie, we always want it to be, at the very least, in an alerted state. So we're going to do exactly the same here by saying if zombie state machine.visualthreat.type equals AI target type.visual light, well, then we set that visual threat as the new current target of our zombie state machine, and we reset the timer back to its max duration. Now remember, there's not an else clause between these two conditionals here, so even if there is an audio threat and we set that as the target, it doesn't matter, because if we come down here and then we find there's also a visual threat that is a light, we're going to just set the target again to the visual threat, overriding anything that we set up here. Notice how none of these conditionals return from the function. That's because we need them to fall through to further down the function where we're actually going to do some processing to see if the audio threat or the visual light is within the player's field of view. And if it is, then we'll transition out into the pursuit state. So the next thing we're going to do is we're going to handle the case where the current threat might be the lowest priority threat, which is food. So in this conditional, we say assuming there isn't an audio threat, because we wouldn't want to override an audio threat that we set up here, and assuming that the visual threat is food, the lowest priority threat, well then this conditional will be executed. And it handles very much like the visual player threat, because food is only a threat if it's within your view cone. So we simply set the visual threat as our current state machine's target and return from the function, transitioning us into the pursuit state. How does this look in the game? Well, if the zombie is seeking left or right, it finds that some food has come within its view cone, it's going to transition into the pursuit state, which is going to have it running in a straight line straight to that food. And of course, when it gets there, it will transition into another state that we haven't invented yet. That's going to be the feeding state. It's going to see the zombie go down onto all fours and start feasting on the remains. Now this can look a little bit confusing at the moment, because it's kind of like, why are we returning from the function immediately for the visual player and the visual food, but we're not for an audio threat or a visual light? So let me just explain, and I'm sorry if you already get this and it seems like I'm being redundant, but it's just such an important part. Now, the visual light is a very special case, so let's assume for the moment that it didn't exist, that the only threats we had were visual player and visual food and audio. Now, visual threats only ever become threats if they're within your view cone. You may remember this from a few lessons ago. So there's never an instance where we are seeking to find a visual target, because the sheer fact that it's already a threat means that we can see it, and therefore we should always, irrespective of the state we're in, go straight into the pursuit state and start tracking towards it. An audio threat is of course very different. An audio threat can happen behind you, and therefore just because we're in the seeking state and the target threat is an audio, it doesn't mean that we're aligned with that audio yet. It doesn't mean we're looking at what we consider to be the source of the audio. So that's why later on in the function, the code we're going to write in a minute is going to see us seeking left and right, trying to get that audio source, the actual source of the emitter of that sound, within our view cone, and when we do, we'll transition into the pursuit state then. Now, why this seems so convoluted is that although the flashlight is a visual threat, just like visual player and visual food, it's handled very differently. It's not something that comes within the view cone. It's actually handled by a trigger that is on the flashlight object. The flashlight trigger is what's going to detect when it's illuminating a zombie, and will essentially push itself onto the zombie's threat queue as a visual threat, but really it kind of acts more like an audio threat. So that's why for these two threats, and only these two threats, when we're in the alerted state, these are the only threats that really can keep us there. Any other threat means that we can see something already, and we no longer need to seek. So if we get down to this point in the function, it means we either have a visual light threat, an audio threat, or our current target is a waypoint. If it's a visual light or it's an audio threat, what we're going to do is we're going to measure the angle between our forward vector and the vector from ourselves to that threat. And if we find that it is now within our view cone, we will force ourselves into the pursuit state. But if it's a waypoint, what we'll do is something very similar, but instead of creating a vector from our position to the threat, we'll be using an angle between our forward-facing vector and a vector from ourselves to the steering target, the next waypoint along our patrol path. So I think in preparation for writing that code, what I want to do is add two more variables that can be exposed via the inspector so that we can set the angle thresholds at which we consider ourselves aligned with the target and come out of the alerted state, either into the patrol state or into the pursuit state. And I think I'm going to have two different thresholds, one for when we're just trying to align ourselves with the next waypoint. So we're going to really want that to mirror the same number that we use to drop out of the patrol state and into the alerted state. So I think that was 80 degrees if I'm not mistaken. Let me go back to the editor, choose our AI entity, and let's have a look at our patrol state. I say 90 degrees actually, so you can see that when we're in a patrol state, if the angle between ourselves and the next waypoint is 90 degrees or more, then we're going to drop into the alerted state to do a turn on the spot. So I think once we're in the alerted state, we need to say that if we've turned around such that the angle is now less than 90 degrees, then we're going to go back into the patrol state and resume following our patrol path. When we turn on the spot when we're following a waypoint path, that's purely being done for aesthetic purposes, so we don't see spinning on the spot. But when we're rotating on the spot trying to ascertain the source of a sound or a flashlight, then I think we want to be a little less forgiving. We want them to really turn around and get very much aligned with that, because it's going to look better anyway when we look at it. If we see a zombie that is trying to find where the sound we've just made is coming from, we want to see that zombie sort of seeking left and right and really turn around and align itself with where the sound came from before it starts running towards us. So I think what we'll do is we'll use a much smaller threshold of, say, something like 10 degrees for that. So it's another private field that we're serializing, so we use the serialize field attribute. It needs to be a float because we're representing an angle, and I think I will call this one waypoint angle threshold. And like I said, by default we'll set that to 90 degrees just because that's what happens to be set as the threshold in our patrol state to drop into the alerted state. We really want our waypoint angle threshold in our alerted state to really be the same as the turn on spot threshold in our patrol state, or otherwise we might have ourselves a kind of ping pong situation where we drop into the alerted state because the angle is, say, 90 degrees, and then we find ourselves going straight back into the patrol state because our waypoint angle threshold will say 100 degrees, but then as soon as we get back into the patrol state, because the angle is larger than 90 degrees, we drop back into the alerted state again, and we end up just being stuck in a loop ping-ponging between both states. So we really want to make sure that these two angle thresholds that are shared by both the alerted state and the patrol state are set the same. But we don't have any such concerns with our other angle threshold, which is used purely when tracking legitimate threats such as an audio source or a light. So I think I'll call this one threat angle threshold, and for now we'll just set that to 10 degrees. Now 10 degrees might be a little too unforgiving, but until we create the pursuit state in our next video, we're not really going to be able to know or really be able to test it. Okay, so let me just save that off, go back to the editor and just check they show up in the inspector. Yes, they do. There they are. So now I'm going to go back, scroll down to our onUpdate function and continue writing the code now that uses those two thresholds with the various threat types to see whether we need to seek left or right or drop out into another state. So I'm going to declare a local variable of type float called angle, which I can use to store the result of calculating the angle between our forward vector and whatever our target is. And I think the first thing I'd do is I'll handle the case where it's not a waypoint we're trying to align with. So it's either an audio source or a light. So I will say if zombie state machine.target type equals AI target type audio, or if zombie state machine.target type is a visual light, well, that means we need to calculate the angle between our forward vector and the vector from ourselves to the position of the threat. And we get a chance to use our find signed angle function, which we wrote in the last video, thought we were going to use, and then ended up not needing to use it. Well, now we do need to use it because the sign of that angle is going to tell us whether we need to seek left or right. We will say angle equals and then we will use our AI state class's find signed angle function, and we will pass in as the first parameter our zombie's forward vector, the direction in which our zombie is facing. And as the second parameter, we will create a vector from our current position to the position of the threat, be it an audio threat or a visual light threat. And of course, what angle will contain is that signed angle. So if it was 10 degrees to the right, it would be positive 10. If it was 10 degrees to the left of us, it would be negative 10. So if the target type that we're tracking is an audio clip, and the absolute value of the angle that we just got back is smaller than our threat angle threshold, then that means we've aligned ourselves with the audio clip, and we should go straight into pursuit mode and start heading off towards that location. So as you can see, I say if state machine.targetType equals audio, and if the absolute value of our angle, we're just temporarily removing the sign for this test, is smaller than our angle threshold, well then we have managed to turn on the spot such that we are now aligned with the target, around about 10 degrees or less. So we will drop out of the alerted state and into the pursuit state. Now once again, you're reminded we haven't written the pursuit state yet. We're going to do that in the next lesson, but that's the state that's going to see us plot a path to the target, and in the case of this audio source, it will look like our zombie is heading off to investigate the source of that sound. Okay, so one of the things that might seem a little odd is that we're only executing this code here in the case of an audio clip. So what happens with a visual light source, which is, remember, the player's flashlight? What happens if we've aligned with that? Why haven't we got code here that drops us out into a pursuit state? But of course we don't have to, because the visual light is the player's flashlight. So at the point where we've rotated around enough such that the visual light comes within our field of view, well, at that point this code will be triggered instead as the highest priority, because as soon as we can see the source of the flashlight in our field of view, the actual player himself will be in our field of view, and therefore this code will execute and put us into a pursuit state earlier on. But assuming we haven't yet rotated around enough such that the audio source or the visual light source is not within our threat angle threshold, well, then we need to determine, do we need to rotate more to the left or do we need to rotate more to the right? And we also want that decision to be further influenced by the intelligence of our zombie. If our zombie has a high intelligence, then we wish it to turn almost always in the right direction so that it is always able to align with the target. But in the case where a zombie has low intelligence, then we might just choose a random direction so that it stands a good chance of seeking in the wrong direction up until a point where the timer expires for our alerted state, and the zombie just gives up and carries on his way on his patrol route. So because our intelligence value, if I just go back to the editor a minute and unfold our zombie state machine, our intelligence value here is actually a value between 0 and 1. So what we'll do is we'll just generate a random number between 0 and 1, and if it's smaller than our intelligence, then we will make an informed decision about which way to turn. But if it's larger than our intelligence, which of course will never be the case when intelligence is all the way up to 1, well then we'll just do a random turn direction. So the more that we pull this down towards 0, the higher chance we have that a random value is going to happen on the right hand side of our intelligence slider here, and a random direction will be chosen. So what does that look like in code? Well, we generate a value between 0 and 1 by using the random class's value property, and we simply compare it against our intelligence property. So we say if random.value is smaller than our zombie's state machine intelligence property, well then it means we need to make an informed decision. So we will say zombie state machine dot seeking. Remember, the seeking is the property that is fed directly into our animator here. It's an animator parameter which is either -1 or +1 to invoke the zombie turn left or zombie turn right states respectively. We will set that property to the sign of the angle. So if the angle was a negative value, then it means that it's to the left of us and seeking will be set to -1. But if the target was to the right of us, then the mathf sign function is going to return +1, and therefore seeking will be set to +1, and that will invoke our turn on the right animation. However, what we'll also say is if random value isn't smaller than our intelligence, then we're just going to make a random decision about which way to turn. So we will in that case set our seeking property to the sign of, and then we'll choose a random number between -1 and +1. Now let's handle the case where we are dealing with a target that is a waypoint, where we don't want to use the threat angle threshold, we want to use our waypoint angle threshold, and we also don't want to find the angle between our forward vector and the target. We want to find the angle between our forward vector and the next point along our nav path, in other words, the nav agent's steering target. So we will say if zombie state machine.target type equals waypoint, then we calculate the angle between our zombie's forward vector and the vector from our position to our nav agent steering target, and if the absolute value of that angle is smaller than our waypoint angle threshold, then we've already seeked to the left or the right enough such that we are aligned enough with our steering target that we can just resume our patrol route. Otherwise, we will set our seeking variable to the sine of our angle. So if our steer target was to the left, seeking would be set to -1. If our steer target was to the right, then seeking would be set to +1. And I think that is our alerted state complete. Notice how in the case when we are seeking to try and align ourselves with the waypoint, we don't use the zombie's intelligence, because I think that'll look a little bit weird. It's not like in the waypoint case that the zombie is trying to figure out which way to go. We're just dropping into the alerted state there purely for aesthetic purposes. So we don't want the zombie to look confused. We want him to just stop, turn on the spot, and then carry on his patrol route. So the whole idea is that although we've stopped and turned on the spot, it really just looks like it's all part of the patrol state, even though we know behind the scenes we're actually dropping into the alerted state to reuse it for that turn on the spot animation. So let me save that off, go back to the editor and check I haven't got any errors. And I haven't. Surprising. Now you're also reminded before I press play that our zombie turn on left and zombie turn on right states in our animator do use route rotation as well, much like our idle state, whereas our walk, jog and sprint states do not. We saw in the patrol state that we actually rotate the zombie on the spot ourselves in those states. So that's why you haven't seen us have to add any rotational code to our alerted state, because in the alerted state, when one of these turn on the spot states is activated, the turning is going to happen automatically because it's in the animation itself. So if I press play now, we should see our zombie properly patrol its waypoint path. Unlike how we ended up at the end of the last video, you will remember that when we came into this room, the zombie found that it had to do an about turn of 180 degrees, and because we dropped into the alerted state from our patrol state, but the alerted state didn't exist yet, it would drop back to the idle state. So our zombie would just essentially come to this first waypoint and then would just be stuck there. What we should see now is it turn on the spot, and should look pretty cool. So let's press play and see what happens. I'm going to do this in the scene view because it's a bit easier to see what's going on. Actually, I am going to adjust the head rotation actually that we put in last week. So there he is turning on the. Oop. No, that didn't quite look right. Let me see what happens in the next room. No, that's not working right. No, that's not working right at all, is it? Let's have a look. What have I done? Yeah, I think I know what this is. Actually, I was talking complete rubbish earlier. Remember when I said that the waypoint angle threshold needs to match that of our turn on spot threshold so that these two are identical values? Actually, that's completely untrue. That's the last thing we want to do, or that will create the ping pong effect. You see, what's happening is we are in the patrol state, we realize that we have over 90 degrees to our target, and then we're kind of dropping down into our alerted state. We're beginning to rotate a little bit, so it just drops under 90 degrees and then it starts to move again, but as soon as it moves a little bit, that threshold grows more than 90 degrees again, and then we find ourselves dropping down into the alerted state again, and it keeps happening. So actually what we want to do is we want to make the waypoint angle threshold actually considerably less than the turn on spot threshold. So let's say something like, I don't know, 30 degrees, maybe 45 degrees is enough. Now this should work. Yes, I'm hoping. Otherwise, with you guys watching, I'll never work in this town again. Okay, let's have a look. Please turn all the way around. There you go, that's better. Now it's working. So you can see he is correctly using the alerted state when he has a steep angle to turn through, and it looks a lot more organic. It really looks like the zombie is trying to figure out, and it kind of, what's really cool about it is it gives the zombie sort of a perceived intelligence which it doesn't really have, but that the game player will think the zombie has. It really does look like the zombie is searching for you, trying to seek you out. But of course we know it's just that animation getting him onto his next steer target. But you'll notice, see the zombie's head. Remember at the end of the last lesson I was trying to show you that we can rotate the head, and we had the head always looking at the target. That's a really stupid idea. It just looks stupid, and he didn't clear that, did he? So maybe I have to make that the angle threshold even smaller again. Maybe we'll turn it down to something like 25 degrees. I'll run that again and check that when it gets to this point he does clear it. You can see what's happening. He starts running forward because he thinks he's aligned with it, because we've given just too much threshold there. So now we're going to force him to get much more aligned with the route that he is supposed to be going. But you see what I mean about the head? Look, I mean, he's looking in that room over there. Even when he's running up the side of it, it looks stupid. And I think that's because we had the head goal being set to look at the target that he's heading towards. And I think that's only going to work in the pursuit state when he's actually running towards the player or something like that. I think in the patrol state we should probably just have him looking towards the steering target. So I'll go and change that in a minute and fix that. Plus we also get a bit of a head snap, don't we? For the same reason. Hopefully he'll get out of here okay now. There you go. So you can see it's really just a case of tweaking with that threshold to get something that works. Okay, so our waypoint patrolling now works. So just before I fix that head, what I'm going to show you is, although we don't have a pursuit state yet, I'm going to show you the very initial test that our threat system is working. And I'm going to create essentially a mock audio threat. Now remember, an audio threat needn't necessarily be anything audio related. It's really just a trigger that is on the audio aggravator layer and has been tagged with the AI sound emitter tag. Okay, so the idea here is that we would create some sort of trigger that was on that layer with that tag, and it would be on a game object with an audio source, and that game object would be disabled by default. But then when we turn that object on, the sound is going to play, but it's not the sound itself that is going to make the zombie react to that threat. It's the fact that a trigger has just come on the audio aggravator layer. So we can actually create an audio threat without even having any sound. We can just put a new game object in the scene. I think for now what I'll do is I'll just put a sphere in the scene so we can see it, and it's got a trigger on it. I want to make the collider a trigger, okay, because the threat system works with triggers, not colliders. And I'm going to set the layer of this trigger to audio aggravator layer, and I'm going to set the tag to AI sound emitter. And then what I'm going to do is I'm going to turn this object off by default. But I want you to imagine that we have an audio source on this game object, and we might have that audio source configured with play on awake. So as soon as the object is instantiated, its awake function is called and that sound plays. But of course the zombie's not reacting to that, it's actually reacting to the trigger. So I'm going to wait until the zombie runs around the bottom of the bus and is heading away, and then what I'm going to do is I'm going to turn on this game object, and we should see him stop in his tracks. But before we do that, let me just turn off the... Actually, no, I'm going to leave the renderer on so that you can actually see the visual feedback in the scene view. You'll be able to see when I've enabled it. But what we do need to do is we need to up the radius of that trigger so that our zombies collider is definitely inside it. Okay, you ready? So I'm going to turn the sphere off. I'm going to press play. Come on, Jill. You haven't got all day. I have actually. I've got all day. Okay, so when it goes around the bus, I'm going to turn it on. 2, 3, 2, 1, now. Look, he's stopped in his tracks, he's heard a sound, and now he's turned around to face it. Now he's not going to do anything yet, but when our pursuit state is there, you can see because he's an intelligent zombie, he's going to start heading straight towards that sound source. Even though I've turned that sound source off now, it's going to remember where that target is, and it's going to go and investigate the source of that target. So even if the sound only plays for a couple of seconds, that'll be enough to get the zombie's attention. When the sound stops playing, it won't be dumb enough to go, oh, I didn't hear something. It's going to say, no, I damn well heard something and it was coming from that direction, and I'm going to go and check it out and see if there's anything there. Of course, we can't see that last little bit because that involves having the pursuit state written, which we haven't. But you can see now that our threat system is working. Now, someone asked on the forum whether our AI zombie system could handle other senses such as smell. For example, could our zombie react to the smell of blood? Well, actually, yes, using this exact same system, because although I've called the audio aggravator and the AI sound emitter things that make it very specific to sound, of course they're not. They're just triggers that the zombie reacts to. So we could use this exact same sphere that I've just put in the scene on the audio aggravator layer, tagged as an AI sound emitter, or you might create some other tags, and we could use that for smell instead. So we could just say that as a zombie is patrolling on its route, when we turn this thing on, all of a sudden, let's just say, for example, the player, I don't know, cuts himself, ba-boomf. This trigger is turned on, the zombie's running past, and it would seem like he was smelling blood. And he would turn around and start seeking to the source of that smell. So it's really flexible. You can use it for everything, not just sound. Really, the audio aggravator is just any other sense, just anything that can aggravate the zombie where the threat itself doesn't need to be in the player's view cone, like normal visual threats. Okay, so I'm going to remove that sphere from the scene, and finally I'm going to fix the head, because if I just zoom in again, so you can see the head of the zombie, it does look a little bit monstrous, with him always turning his head whilst patrolling his waypoint route to look at the target. It should be looking, look, it looks kind of crazy. He's running around this wall, but he's looking in that room before he gets there. It looks even crazier over on this side when he's running up this little corridor here, because the target is actually in this room, look, but he's looking to the left, which just looks lame. So that code is in our patrol state. So I'm going to scroll down to the bottom, and I think it should be in that function that we overrode called onAnimator IK updated, and it's where we set the lookout position. As you can see, we're currently setting the position to be our target position. Of course, that target position isn't the next point on our path. It could be several steering targets away. And indeed, we saw that just now when he was running up that corridor and the room was to the right. He couldn't get into that room until he turned 3 more corners, but he was still trying to look into that room through the wall. So what can we do about this? Well, one of the things that we could do is, instead of using the target position, we could use the steering target. But the steering target is not going to work either, because it's going to look very jittery. Because if we look at our nav mesh and we plot a path across our nav mesh, every vertex on our path is a steering target. So there's going to be lots of steering targets, and they're going to be changing very frequently, and we're just going to see the head flicking between them all. So I don't think the steering target is what we can really use here, unless we put a great deal of smoothing in and maybe even some lerping in, which frankly I just don't think it's worth it in the patrol state. Like I said, in the pursuit state, what we've got here will work just fine. We want the zombie to be looking at the player when it's running towards the player, but in the patrol state it doesn't make sense to use the target position or the steer target. So the other thing that we could do if we wanted, but would also require some work I think to get right, and maybe some smoothing as well, would be we could actually just set the lookout position to be our current position plus our desired velocity. And when I say desired velocity, I mean the desired velocity property of our nav agent, because that would at least give some independent movement between the head and the body of the zombie itself, because our desired velocity is often a little ahead of what our actual velocity should be. So if the zombie was turning onto its desired velocity but hadn't quite reached it, the head would still be looking in that direction. Now, I'm going to just let a little cat out of the bag here. I've already tried all of these things and didn't really like any of them for the patrol state. In fact, what I want to do for the patrol state is comment out this function altogether. I actually don't think our patrolled state needs this independent head movement, but I'm going to comment it out instead of deleting it, because this is pretty much the exact function that we want to copy and paste into our pursuit state when we write that in the next lesson. But for now, if I just remove that so that we don't try to manipulate the head, I'm still glad we did it in the last lesson, because now you see how the IK goals work and how we can move things like the head using the animator's interface. But if I go back now and press play one final time, you're just going to see that this just looks much more natural, just not messing around with it. And not only that, because we're not always overriding it on a per frame basis, the head isn't getting any sharp jittery movements when we transition from one animation, such as the alerted animation, into our jogging animation, because the head movement of the alerted state and the head movement of the patrol state are being blended nicely using the transitions of our animator states. But of course, when we are overriding that using the onAnimator IK updated, we lose the transitions that are being happening to the head bone, and we're just applying them directly ourselves, so we can get some snapping. But I'm sure you'll agree the head animation there looked far superior to anything we'd seen with just that entire feature turned off. So that's it for me, guys. In the next lesson we will come back and we will write our pursuit state. So thanks for listening. I will see you next time. Bye bye now.